Hello, I'm going to talk about a software-defined networking SDN. I'm Winjo. This is my index. The first one is what is SDN, and I'm going to talk about architecture or traditional network and its weaknesses, and also overflow is a communication protocol, and the fourth one is network function virtualization (NFV) is also related to the SDN, and the benefits of SDN and challenges of SDN. The last one is a conclusion. The first, what is SDN? I would say SDN is an approach to networking that use software-based controller or maybe application programming interface (APIs). The main reason is to communicate with underlying hardware infrastructure and direct traffic on the network. And also administrator can control the network and change and configuration setting and provision resources and increase network capacity. Therefore, they configure all from the centralized user interface called API without the need for more hardware by putting the more hardware. In SDN move to the control plane, which is determines where to send the traffic to software, and then there is also the data plane, which actually forward the traffic in the hardware. The data plane will be the switch or maybe routers in your network. This is SDN infrastructure. You can see that forwarding devices like router, and also they have southbound APN and northbound APN. There is also the global network build, which is controlled by controller, SDN controller, and also they have a abstract network build, app 1 or app 2, some etc. etc. So this is the SDN architecture. You can see in this topology. And now I'm going to talk about architecture of traditional network and its weaknesses. As you can see, as you know, in traditional network architecture, the control plane and data plane are integrated, which means, so if you want to configure one of the device, you need to go to this device and configure manually, because this is not a centralized. They don't have a centralized controller, because in one device and control plane and data plane are integrated. You can see in this picture, there is a router, and each one of them have a control plane and data plane. So if you want to put more router, or maybe if you want to change something, you need to configure, or you need to change every single one of the device in your network. It's really cost time, and it's also based on the bandwidth specific. Is the overflow. Overflow is a communication protocol in SDN architectures, which is enable the SDN controller to directly communicate with the forwarding plane or network device such as a router or switches, and also both physical and vertical hypervisor base. In this picture, you can see we have 3 controller, and also we have a float data plane devices such as router or switches something. So in between, to communicate with each other, there is a open flow protocol. It can even to communicate a controller, control plane and data plane. I'm going to talk about network function virtualization. NFV is also very important in SDN software-defined networking architecture. So SDNs provide the basic networking functions, and also SDN assumes higher level management responsibility. to orchestrate overall network operations, which means that SDN control other management and NFV control, which is related to the basis and networking function. You can also run on the virtual machine, hypervisors, network controllers, a load balancer, and also gateway are deployed by the network function virtualization to provide the needed network infrastructure controls. This is a topology which is related between software-defined networking and network function virtualization. You can see the portal. This is so from the Google. Now I'm going to talk about benefits of SDN. We have a lot of things. The first one is energy management. We can manage the energy which are running in your infrastructure, network infrastructure, like a switch or router or maybe server. And also it's also directly programmable. And we can also use network function virtualization in SDN. And it is also the centralized management. We don't need to configure every single one of the device in your network. You just go to the controller and just change something in this controller, so it will affect all entire your network infrastructure. So it can also reduce capital expenditures and also operational expenditures. So it's also a bit flexibility, and it allowed and even innovation. And you can also change network management, and also resource utilization is better than a traditional network architecture. Okay, also we can also use big amount of bandwidth in SDN architecture. The last thing is challenges of the SDN. So they don't have standards, the common standard about the SDN setup, because it's stay in a research area, and it have also don't have a quality of service. How can they support for the quality of service? And also scalability. It is stay in a research area, so more researchers stay develop SDN, not interested in stay in research. So as you know, our network environment is based on fuzzy nature, so we have a lot of big network like internet. So now SDN is stay in research area, and it doesn't improve in industry. So we need to develop, and we need to take time to deploy SDN in industry. And also there is a lot of expensive to deploy SDN in your network, and it also need a lot of standards and how to deploy your SDN in your network. So it's a lot of problem challenges, but it's still improving year by years about SDN. This is my conclusion. The first one, in traditional networks are complex and hard to manage, and also typical network devices are also tightly tied to line products, and version is also based on a vendor specific. And in traditional network, the control plane and the data plane are vertically integrated. So if you want to configure something, you need to go each one of your devices and manually do step by step. It's really hard for the network engineer. And in SDN networks, so it decomposes the control plane and data plane. In control plane, there is the global view of the network, biologically centralization of the network plane called controller. And the last thing I would say, the SDN represents the major paradigm shift in the deployment and evaluation of the networks, introducing the new pace of innovation in network architecture infrastructure. So it means in the future, SDN will develop more in industry and like a Google or maybe Facebook, they will use SDN instead of traditional network because of many benefits than traditional network. Thank you for your attention.